Imagine being able to see the invisible forces, the subtle shifts deep inside our planet with incredible clarity.
It sounds like science fiction, almost.
Right. But NASA scientists are proposing something close, putting a quantum gravity gradiometer, a QGG, on a satellite.
In low Earth orbit.
So our mission today is to unpack this. How does it work? And maybe more importantly, what are the implications? Especially for, areas relevant if you're preparing for the UPSC exams.
Exactly. This tech touches on climate, resources, security. Lots of key areas. The source for this, by the way, is an interesting piece in the Hindu.
Good stuff. Okay, let's start with the basics. Gravity. We all know it pulls things down.
Right. It's the attraction between masses. More mass, stronger pull. But the Earth, well, its math isn't perfectly even.
Like mountains versus oceans or denser rock formations underground.
Precisely. So the gravitational pull actually varies slightly from place to place.
Yeah.
Tiny variations.
And that's where a gravity gradiometer comes in. How does that work then?
So it doesn't just measure gravity. It measures the difference in gravity, the gradient, over a very short distance.
Like how rapidly gravity changes as you move slightly.
Exactly. Think of it like feeling a slightly stronger pull here compared to just a meter away, because there's more mass directly below here. It detects that subtle difference.
Okay, makes sense. Now, the quantum part. What makes a quantum gravity gradiometer special?
That's the leap. It uses quantum mechanics. Basically, they take atoms, cool them down to near absolute zero.
Super cool.
Extremely cold. So cold the atoms start behaving like waves, quantum waves.
Okay.
Then they use lasers to manipulate these atom waves by measuring tiny shifts in how these waves interact. Shifts caused by gravity, they could detect incredibly small differences in the gravitational field.
How small are we talking?
We're talking sensitivities around 10 nanometers per second squared. It's phenomenal sensitivity.
Wow, that's hard to even picture. And putting this incredibly sensitive thing in space, why up there?
Well, putting it on a satellite gives you a global view. Consistent, repeated measurements over the entire planet, away from ground-level noise and disturbances.
Right, a clean, big-picture perspective.
Exactly. You can map the whole Earth's gravity field and how it changes over time.
Okay, so we have this ultra-precise gravity map from space, constantly updated. Let's connect this back, especially for our listeners focused on UPSC topics. How is this useful?
Oh, hugely useful. Take climate studies, for instance.
Does so.
It can track shifts in large masses of water. Think melting ice sheets in Greenland or Antarctica, or changes in groundwater storage in large river basins.
So you can actually weigh the ice sheets from space, in a way. See how much mass is being lost.
That's a good way to put it. It gives us direct data on water movement, vital for climate models and understanding sea level rise.
That's critical. What about finding resources?
Definitely. Variations in gravity can indicate different densities underground. This could help pinpoint potential locations for, say, mineral deposits or hydrocarbons, or even hidden aquifers.
Without needing to drill everywhere. Less invasive exploration.
Exactly. More efficient and potentially more environmentally friendly.
Okay, climate resources. You mentioned national security, too.
Yes, potentially. Mapping subsurface geology with this precision could help monitor underground infrastructure or detect geological hazards near critical sites. It offers a kind of subsurface intelligence.
Interesting. And even archaeology, how would that work?
Well, buried structures like ancient ruins or tombs often have a different density than the surrounding soil.
So they'd create a tiny gravitational anomaly.
A very tiny one, yes.
Yeah.
But a QGG might be sensitive enough to detect these subtle density contrasts, helping archaeologists find sites non-destructively.
So it's really about reading these subtle gravitational clues to understand what's happening both on the surface with water and ice and hidden beneath our feet.
Precisely. It's a powerful tool merging quantum physics, satellite tech, and earth sciences.
It really gives you a sense of how interconnected these fields are and how advancements in one area can unlock insights in others, something very relevant for that interdisciplinary thinking needed for the UPSC.
Absolutely.
So just thinking aloud here, if we can see beneath the surface with this kind of precision, what else might we discover? What challenges could it help solve that we haven't even thought of yet?
That's the exciting part, isn't it? New tools often lead to unexpected discoveries.
Definitely something to ponder. We hope this deep dive has clarified this fascinating NASA proposal and its potential relevance, especially for your UPSC preparation.
Yeah, it's a technology worth watching.
If you found this useful or have more questions, please do like, subscribe, and leave us a comment. We'd love to hear from you.
And remember, this discussion was informed by reporting in the Hindu.
Thanks for tuning in.